Excellent. Welcome to our second lecture on acids and bases, where I'll be enjoying telling you about all the vocabulary for the unit. Okay, so I'm not sure if the webcam's integrating. I hope it is. Let's get to our special words of acids and bases. Okay, so unit vocab, acidic. Well, that is something that's extremely acidic, touching a nitrile glove. Boom, crazy. But what is acidic? Acidic is a solution with a pH lower than 7. Has a higher concentration of H plus ions. And in the margins here, right in parentheses, H3O plus, hydronium. Okay, so hydronium ions, aka H plus or H3O plus, make a solution acidic. And anything that produces those when it touches water is considered an acid. The opposite of acids are bases. And sodium hydroxide is a base. Hydrochloric acid is an acid, obviously. They both react with metals, some more vigorously than others, as you can see in this particular video. Can we do that, Mr. Monaco? Sure. Bring in your aluminum cans. Basic is a solution with a pH higher than 7, an elevated concentration of OH negative, aka in the margins, hydroxide ions. So when I say hydronium, I mean acid, and when I say hydroxide, I mean basic. And those are the characteristic things that acids and bases produce when they touch water. Now, the next word is alkaline. And this is a picture of a reaction of an acid or a base. It's called a stopwatch or a stoplight reaction. It has to do with alkalinity and basicity. Alkaline is just another word for basic. Okay? Basic and alkaline mean the same thing. Now, the two different types of Arrhenius, acids, Arrhenius bases. Well, when you add an acid to water and you get H plus, aka H3O plus ions, that is an acid. So a compound, any compound that produces H plus, aka H3O plus, as the only positive ions in solution are considered acids. So that is one of the properties of acids already in the definitions. Arrhenius base is when you add a base to water and it produces OH negative, aka hydroxide ions in the water. So these are the only negative ions in the solution, and we call them hydroxide ions. So bases produce hydroxide. Acids produce hydronium. That is what they do. That's the basic distinction between them, pun intended. And here's our hydronium ion. It's when a water molecule soaks up that H plus ion that the acid releases. It makes hydronium. So the hydrogen ion, H plus, reacts with the water that's necessary for acids and bases to exist and creates this hydronium that you see on the right-hand side, H3O plus. It's like you add another H with its positive sign to a water molecule. So the definition, H3O plus ion. It's a synonymous with the H plus ion, and these make a solution acidic. If the compound produces those, it will be an acidic solution, and the compound can be called an acid. Hydroxide ion is a little different on the other hand. Hydroxide, well, that reacts with water too, but it only produces the OH negative in solution. So we've got hydroxide, OH negative, makes a solution basic. Hydroxides are easy to spot in chemical formulas, and therefore any chemical formula that contains a hydroxide or hydroxide in its name is something that is basic. Okay. Alternate acid-base theory. There's many theories on how acids and bases really truly work. Arrhenius is one theory, hydronium and hydroxide ion production. The alternate theory says that some things are bases because they accept ions, hydrogen ions, from other things. And that's why ammonia, although it does not contain any OH negatives, is considered a base. This theory explains why ammonia acts like a base even though there's no OH negative hydroxide in its chemical formula. So we needed another theory to explain certain chemicals and their behavior. A Bronsted-Lowry acid is acid-base conjugate pairs. Okay, this is rather complex stuff, and it's just another alternate theory. So we don't have to know much more about it than this, is that acids give up H pluses in solution. That's exactly like Arrhenius' theory. Arrhenius' theory said an acid is something that produces H plus in solution. It went one further step and said that H plus reacts with water to make H3O plus, which is also part of that Arrhenius theory. But Bronsted-Lowry backed it up, said, I'm a cosign on that. Bronsted-Lowry base, on the other hand, says, well, a base is a proton acceptor, an H plus acceptor. So the Bronsted-Lowry base says, okay, you don't have to have OH negative in order to be a base, but you do have to be able to soak up H pluses. So Bronsted-Lowry acids give up H pluses, givers. Bronsted-Lowry bases are H plus acceptors, takers, okay? Those are different theories. We'll get into those in lecture 3 soon enough. An electrolyte. An electrolyte is any substance that allows water to conduct electricity because it has dissociated. Well, acids and bases both do this. So acids and bases are both electrolytes. Okay. An indicator. Acid-base indicators, there's so many indicators, but the cool thing about them is that they change color. Yes, pretty colors. And so you'll get to familiar with at least 6 of them. And these are technically dyes that change color due to changes in pH. Changing pH changes the molecule's shape, and therefore it changes its color. And we've been able to use these to accurately measure pHs of solutions, and we call them indicators. Neutralization is when an acid and a base come together, boom, and they trade some parts. Okay, HCl and NaOH come together, and instead NaCl leaves and H2O leaves. So these two acids and bases bump into each other, collision theory, and react to produce salt, NaCl, or a salt, a type of salt, calcium chloride, etc., and water, H2O. So neutralization is acid plus a base reacts to produce water and a neutral salt. Acids and bases, when they react, produce neutral pH 7 stuff if the concentrations are played on correctly. The pH scale is something you're actually probably already familiar with. It's a scale that goes from 1 to 14. And in chemistry, give credit to the fact that it's a negative log of the H plus concentration that measures acidity and alkalinity from 1 to 14. We're going to relate concentration to the pH scale in a later lesson, and that is what the pH scale is really trying to show us, is the concentration of acid or base, not necessarily just the number. The pH number doesn't mean much unless you convert it into concentration, and that's what chemists love to do. Titration. Watch carefully, because that's exactly what you're going to do. You're going to mix an acid with a base. One of those beakers has a base. The burette has an acid. You're going to mix them carefully and measure the concentration of the acid or the base. So it's a neutralization reaction that you tailor very carefully to reach the end point to find the concentration of the base that's in the jar, or I'm sorry, the concentration of the acid that's in the flask. Okay, some more words. Salt. Common, coming back. It is an ionic compound produced from positive and negative ions that is produced in an acid-base unit when an acid and a base react. They produce a salt and a water molecule, so that's why we had to bring salt back. Dissociate, another word that came back. It's when a chemical compound breaks apart into positive and negative ions when it hits water. Acids and bases both dissociate. It's why they are electrolytes. So it's when the atoms break apart in solution, forming an electrolyte, because there's positive and negative ions at play. Which leads us to another very common word, ion. It's a positively or negatively charged atom. Okay, it has lost or gained electrons, and that is what is being played with acids and bases. Simple enough. Molarity, another word coming back from a previous unit because we have to measure concentration of acids and bases. It is the moles of solute, aka the acid or the base, divided by the liters of solvent, the water that they must have in order to do their jobs. Concentration, another repeat word. It is a relative comparison of how much solute is in the solvent. In acids and bases, a low pH means there's a lot of H plus, aka H3O plus, and in bases, they have lots of OH negatives. Okay, so concentration relates to hydronium ion concentration, the amount of solute per solvent over solution. Okay, that's a measurement. So that is the end of our lesson on vocabulary. See you later. Lesson 3, theory, coming right up. Turn off the video.